start to the fast version and being annoyed. Somebody popped in already and then they popped back out. Let me pause recording because there's nothing going on to do. Yeah, okay, so this is Coffee Compiler Club, and anything to do with compilers and language runtimes and typing systems and I don't know, garbage collection and threading models and eval security, which I got hammered on over the last week, is all fair game. It's open mic. I reserve the right to moderate. Never had to do it. You're being recorded live. You're going to show up on Twitter, videos, YouTube, and probably in only an hour or two now. It's much more exciting. And that's it. It's fair game. So it's good to go. So I'll do an AA status dump, which I haven't done in a while, which is to say I'm in theory, I'm in the same spot I was a month ago, but I think actually I'm well ahead. I've had this other fellow, Marco Cervetto, like beating on my typing system, and he keeps finding exciting holes. That the kind of holes he's been finding has been slowing down. So I think I'm like closing in on actually having something that's sound and complete. And I'm busy backporting it to the main AA code base from the research prototype piece. So that's where it's at. That's a work in progress most of the time. Then spent the last several weeks like sorting out bugs that were deep and subtle looking, and they usually had like one little line of code had one little negate or add or this flip for that flip thing had to be done, and suddenly it was all better, and a bunch of other junk I had floating around to fix the problems in a bad way could be removed. So that's my status update here.
What were the tests that were finding your corner cases for you? The like church and code numbers and try to do math kinds of things?
Or doing more people adding in. The last several ones started from doing, piano math, writing piano arithmetic primitives in AA syntax, and doing type inference. And do you infer the type of numbers, of piano looking numbers, right? So it's kind of ugly looking, short, simple, ugly looking code. And I can throw examples up in the docs. They're like brutal to read through. And they're not very long. They're just brutal to read through. That's actually not a bad answer. And then like the last several ones were places where I was incorrectly claiming that I could keep a subtype where I couldn't, or I was losing a subtype when I should not have. Was the sort of things going on. Let me go find. I added some I don't want to forget, and then I want to go for the example in the chat box. Here's this. Okay, we can go back to the what's an ugly example here. I can show a simple example here. Here's some ugly example of the kind of thing I'm dealing with now. Find the chat. Okay. Example of piano math. Okay, so there's the puke in the docs. It's obviously broken up with comments and strings because it's turned into a test case. So somebody wants to like whack the string syntax off. It's all and turn it into, here I can do this. I'll turn it into code, whatever. There's a font, Robo Mono, right? There you go. Now I need an auto coloring for this stuff, but like it says void equals an empty struct. An error takes a nothing and returns error on the nothing, and what that means is it's a function that's self-recursive. Oh yeah, the link to chat link was back. There we go. Yeah, the latecomers don't get the chat link. There it goes. It's in the chat now. So error just is like self-recursive function that bottoms out. Then B equals, that's Boolean, and there's a true and a false, which has an and an or, and a then else. And if you scroll way down, there's an in equals, so that's number, there's a 0, there's a successor, then there's some math at the bottom, or 1, 2, and 3 are all computed. And there's no types in there at all. This is just structures and fields and shit. And now go infer types on this. So it's like brutally ugly. And I just didn't have things correct in different places and got it sorted out. honestly, I say it's brutally ugly, but it really should be straightforward for a Hindley Milner that has structures. I also do nillable checking, and then I do the whole global constant propagation integration, which doesn't matter for these examples. So kind of, this is where we start from this, and somewhere along the way, something doesn't pan out right. This example now works. Something doesn't pan out right, and then we chop it down and chop it down and chop it down. And suddenly I get a tiny example, and it's like, oh yeah, of course. And then I had a bunch of crappy things I didn't do right elsewhere to cover up for the sins of the whatever. And then I fix it from the base case, and then the complicated fix-ups afterwards are all unnecessary and can be removed. And that's been the status of affairs the last couple of weeks.
I mean, get the axioms right, and the rest tends to clean
yeah,
up.
right. Yeah, exactly. Get the axioms right, the rest kind of falls out. I guess some of the other stuff going on here is that in a classic Hindley Milner, you do a lot of, well, you do unification everywhere, then that's part of the deal. But you do a lot of make a fresh copy for every time you see an identifier, and then you unify it. And that turns into the slowdown or the cost of doing typing, because the fresh copy is a structurally identical new type variable. So it takes all the structure of the old one and clones it with its entire nested recursive in and out structure, and then unifies it immediately. Most of the time, unification makes no progress and does nothing. So the copy was redundant. And so I have a version of unification which lazily copies the left-hand side and then unifies into the right-hand side. That cuts down hugely on the amount of bogus temps that you get made that do nothing except get made and unified for nothing. But
Does that make the compile time less predictable?
I don't know. Like, I don't know if that removes an asymptotic cost to Hindley Milner or not. In practice, all the examples appear to become linear time, except the one which was intended to blow out the standard Hindley Milner algorithm, which kind of looks like it went n squared, down from like n cubed or whatever the normal Hindley Milner is. But Hindley Milner is usually linear in practice because people don't write this kind of shit for real. This is a, break me now test case, so it has ugly shit in it. So I don't know, maybe it doesn't make any difference, maybe it does. But I end up with two copies of Unify, and they're slightly different because the left-hand side is always asking the question, would I make any progress if I bothered to unify on the right-hand side or not? And then if I do, can I just declare unify without actually allocating anything? So it's a little bit different.
You say linear. What is that linear with respect to? The number of types in the system, the number of assignment points in the system?
It's the ratio between the allocated type objects that I end up ultimately in the end counting all. Just have a counter, 1, 2, 3, 4, 5, just counts type objects. Everyone gets a unique ID. And the set of program points, so syntax elements and an AST, they appear to have a linear relationship. The larger the tree, the more types they get, but they don't appear to be growing enormously. So
I mean, you can't have more types than nodes on the tree, so.
No, exactly. The ones that blow you out totally do. So the blowout one is just like heavily repeated, whatever, and the resultant type you get out appears that it's going to grow like exponentially. But I think it grows quadratically or something. It grows fast.
Yeah. The worst case is exponential.
I'm sorry?
The worst case in a Hindley Milner is exponential.
Okay, I can believe it. The worst case that I have grows very quickly. I didn't run it big enough to verify an exponential growth, but it was clearly beyond linear and probably beyond quadratic. So I was assuming cubic, but I don't know, it's not good. I just pulled it off the interwebs and said, hey, look at this example. It's supposed to blow you out. And I said, okay, let me try it. Sure enough, it's ugly.
Just Googled for example that makes Henry Milner sad?
Yeah. It's all good. Let me dump the chat. Hey, Will, let me dump the docs chat again. Okay. So anyhow, wrap it up. The AA theory typing piece is currently stable until it becomes, known buggy again. And so I'm back to porting it to the main AA code base, which is going fine, actually. It's kind of getting there. So AA master is still like completely busted, but I'm hoping, by next week, AA master will pass all tests in all modes.
So is your next step the interpreter, or?
Yeah, there's a bunch of things I want to do with extensions to the type system to see that I can do them, but
Where do you heading next? In
exactly.
terms of
But
types?
it's like an interpreter makes such a huge difference in understanding the quality of the language because you could actually start to write code. Like there's a bunch of things I know I don't do that I want to do. Like integers are totally primitive. Ints do not have a hash code, but I want them to have a hash code by default. If I know that you're a strongly typed primitive int, you fucking have a hash code without having to have a function that says, give me a hash code of an integer. No, it's the other way around. The integer just has a hash, which means I can pass it into a hash table directly as a key, right? Integer should have a dot hash and a dot eq function directly.
I mean, the dumb answer I've usually seen for integers hash is self.
Exactly. Now that's the value, but the implementation, the semantics are right now that integers are really a primitive integer. They don't support any functions. Cameron, I have you in the waiting room and coming in the waiting room again. So you just.
I like you twice as much.
Okay, but yeah. As long as you don't get feedback echoes, it's all good. Right now, the primitive integers don't support any function calls. So I want to change the type that I represent the primitive integer with to basically be a structure type who has fields including dot hash and dot eq, right? And then there has to be a guarantee that at runtime it turns into a primitive integer and has the the cheap, bad, good answer where it's just a number. But you can pass it into a hash function, a hash table, and it'll be a key and it's fine. And then how that actually implements under the hood, there's probably going to be some specialized cloning of the hash code to support people that are objects and have a vtable and people that are primitives and have an implicit built-in vtable. But I have to inline on the spot the implicit built-in vtable. So there's an implementation strategy that's sort of separate. There's a semantics, which is int has a dot hash function, which is obviously self. So
it smells a little bit to me like JavaScript's prototypes, where I'm looking for something and then there's a second place to check, except that there's only two layers. If I'm looking for a dot field, either it exists on the instance or it exists on the class, and those are mutually exclusive.
Yeah.
I can't create an instance value for something that exists on the class or a class value for something that exists on the instance.
No, the instance, it's in the class. So basically, primitive integers have a class. And then I happen to know the class as a compile time constant. So if you have a generic hash code or hash table that calls hash, and in some instances, I'm passing in a thing where I don't know the class. And in some instances, I have a compile time constant class. And furthermore, the compile time constant class is known that I can't fetch it from the instance with any particular mechanism. I must have a compile time constant call to it. Then I need to clone the code. So there's a well understood inlining heuristic to make this work. And sort of but the semantics from the typing system's point of view is there's a class for integer.
But you have to make a choice between cloning and boxing.
Yeah, you have to make a choice between cloning and boxing. In the case of integers, I'll just guarantee you a clone up until some certain level of it, and then I'll demand you ask for boxing, or you get a compile time error saying basically, I have to box this, and you don't want me to. So somebody has to give here. You have to allow boxing, or you have to change your code such that I don't need to box.
Or I have to explicitly tell you, no, I actually meant 32 clones.
Yeah, right. Exactly. So in the case of primitives, there's only like 5 or 6 you care about. So I'll just clone them. You get a couple copies right away, but you won't get 30 copies unless you start asking for it.
Yeah, I think there's something nice in saying like you can clone up to 4 ways. And if you need more than that, either ask for boxing or ask for more aggressive cloning.
Ask for boxing or ask for cloning, yeah. Cloning would be like C++ templates where you explicitly ask for an inline copy, right? This is similar semantic.
But I've seen C++ templates go kind of crazy where you didn't realize something exponential was happening.
With Jim, where he took somebody took a ray trace program and wrote it in C++ templates so that it would ray trace the entire image at compile time, turning into gigabytes of compiler space needed. But the end result apparently was, an array of pixels, which was your ray traced image.
So I've made the opposite mistake of that, where I was doing some work in MATLAB and I was like, oh, generate a PDF for me so I can print the thing. But somehow MATLAB decided to just put the code in the Postscript file, and it took like 3 hours to print because it was rerunning the simulation on the printer in the Postscript file.
Oh,
And I was like, I don't
wow.
understand how I could have done this by accident.
Well,
I don't understand how I could have done this on purpose.
So one of my very, very young man early consulting gigs was I built a Postscript clone. It was a Postscript clone of Apple, whatever, and Postscript's like Forth. I had done Forth implementations that were generating code when I was a young guy. When I was a teenager, I was generating code for Forth. Well, there was a Postscript clone. Hey, it looks a whole lot like Forth. Well, I don't know all about Forth, so I did a Postscript clone, and it would execute your code. Yeah, right. And that was, images were being presented as code to be executed in the printer to print, but no, that would not be a very efficient way to run a simulation. No.
Ask your printer to go print a fractal for you, and it'll just keep rendering till it gets to whatever the pixel
Resolution?
density of the printer is.
Yeah, kind of.
You send that thing to a laser printer, and suddenly it's going to be a while before it prints.
It's going to be a while. So we ran the Postscript according to the rules of running the language. So if you ran a forever loop, you ran a forever loop, and your printer hung. And then the image that we could emit, it was a very, very early laser printer. This was a high-tech startup doing a laser printer. And the printer had some amount of issues, but when they ran the laser across the page, it was at a rotating mirror, and the laser would spin and turn on or off to blink on the, knock the charge on or off, the ink would stick. Okay. There was a limit to how many of these transitions you could do. So you had a manually built bit computer that was running the laser printer, and you stuffed in the line into some memory for the print that would do the line. And then you had to stuff the next line. So it was double buffered. So you'd stuff one line in the next, but there was a finite size of the amount of transitions you could put in that in that buffer. So you then had to, if you had too many transitions, you had to lose some to make it fit on the line. So you just threw away too many very short transitions. Like a fractal would have bajillions of them, and you would just like forget about those. And it would all be shades of gray where it got fuzzy in the middle. And it was, it was 300 DPI was unheard of. People were doing dot matrix printers at, 12 DPI or something. And here was 20 times the resolution. But it was pushing hardware limitations left and right. Anyhow, a lot of fun. But yeah, we would totally like take your fractal and like lose all the complicated bits. Although if you did a photo, it would come out really sharp, because photos don't typically have too many sharp transitions. They have gradual transitions, which we would do because the bit computer understood changing levels. It understood run lengths encoding and changing levels in a linear fashion. So
basically, as long as I don't try to print white noise, I should be fine.
Yeah, exactly.
So basically, it was a denoising algorithm.
Yeah, it was. Yeah. And it did, like I said, did a fine job on photos, did a fine job on many kinds of things. All the printed documentation looked just amazing. Got all kinds of people excited about it. But if you poked hard, you could tell. And the funny thing was, I remember very clearly, after a while, so the laser printer had a couple modes. It would do 1200 DPI. And I got to the point where I could look at a piece of paper from across the room, like walk in the room, scan around, and I could tell you the difference between 300 DPI and 1200 DPI at a fucking glance from across the room. It's amazing.
So did you do all this in an interpreter, or did you have to like JIT Postscript?
Interpreter, schmurters, and machine code. It was assembly. We wrote 68,000 assembly. We wrote a Forth interpreter in 68,000 assembly. The Forth interpreter interpreted Postscript, but Forth is already a language which is a DSL and blends JITting code and executing code seamlessly. No type safety.
So it is a Postscript interpreter written in Forth, and the Forth interpreter is a JITting interpreter written in assembly that outputs machine code.
Yeah, and you can make these things super tiny. The Forth interpreter can be done in under a kilobyte and be full featured. And if you skip types and type safety, you can get these things fucking amazingly small. And then, yeah, you would read the Postscript. You would execute the Postscript, which would basically be a template JIT to spit out machine code for the Postscript. then you would execute the machine code when you're actually executing it. So all code could be run in two modes, the jitting mode and the I'm executing it mode. And it was done with the exact same parsing, the exact same step over the code, just that one would spit the machine code into a buffer and one would execute the buffer. Anyhow, Forth's a fine example of the most earliest kind of blended jitting executing environment around. And you know, the concepts that went into it are spot on and super easy to deal with. And to this
So
day,
would you recommend a student learn Forth and write a Forth JIT?
It's like not even a semester project. I did one for fun in my undergrad for a prof who hadn't seen one go before, and he just gave me an A in the class and told me to get out of here. Yeah, they're like it's like the smallest possible language that does exciting stuff. It has a REPL. It has all your usual computational things and the jitting code and of course just executing code. Kind of, yeah, I think it would be a good, I'm not a teacher, so I can't say what's a good teaching environment. But Forth gets you the distinction between executing and compiling in spades in your face. And it gets you the distinction of what a REPL is and why it's useful. It shows you what a REPL is and why it's useful. And it goes all the way from executing code and language to jitting code and running it in a self-hosting. Like you can totally self-host a Forth system. The amount of machine code you need is on the order of a few hundred instructions to get going. Like you need a way to read from the command line, and you need a way to parse a string, which would just be a buffer of characters in memory, bytes in memory that you're just stepping through looking for white space or not. You need to look up, there's like 3-4 other sort of basic printers you need. It's a couple hundred lines of assembly, that's it. And then you have a basic of Forth interpreter. As soon as you have a Forth interpreter, you self-host a JIT on top of that very straightforwardly. It builds from there on itself really fast. So yeah, it could be. I mean, like I said, I don't know, I'm not the right guy I'm not the teacher here, but it does have all the core concepts. Sorry, Jim.
Forwarded that. Yeah, I've proposed, without naming Forth, I proposed that in the polymorphism issue, that we can turn the stack direction around so that we could potentially, build Forth and currying explicitly.
Yeah, okay. I don't know if I want to go to currying if you're doing Forth. It's like function calls are a funny thing for it, but you have to screw around because Forth does not do currying directly. That would be add-on work. Like when you fire off a function, it just knows its arguments are on the stack and it grabs them without any further ado.
Sure,
Curry,
but the way to arrive at Forth-like code is to curry, right?
Oh, I'm sorry. You're trying to go to Forth. No, I'm saying right in Forth, have a student implement a Forth interpreter. I think it would make a good upper level undergraduate program, undergraduate semester. And the end result is they have a complete VM, basically a virtual machine that does, basic execution, compiling, editing, running code.
And would be faster than most of the languages we use today.
Yeah, it doesn't do any, well, you'd be on the order of Python. I did a template JIT out of it, which probably gets you as good as Python, maybe a little better. It won't be as good as JavaScript because those guys do a hell of a good jitting job afterwards, right? So it's not
talking V8.
Yeah, right. Yeah. Any of the V8 style, there's a couple of them floating around. Any of those kind of guys do all the hard work to actually JIT good code once you throw in all the type safety checks. And Forth just blows off the type safety. If you fuck up, you fuck up, and your house burns down. That's what it is.
So how did you lint that code to make sure your printer wasn't going to throw errors in the wild?
Oh, you just did usual testing. Was it what everyone did testing back in the day before you had any other type safety thing? You got C code, you do testing.
So what would the printer do if there is an error? Would it just freeze or burn?
Well, there's a watchdog timer. So if it froze long enough, the watchdog timer would internally reboot it. While we were testing, we had a lot of things. So we did a lot of our testing on a bare board that had no printer attached to it, that we were just using to see that it would apparently do the right thing, and then we could get a bitmap out that you could look at to decide that this is what the printer would have printed. Mostly the issues were not having the image pre-defuzzed, denoised sufficiently when the paper rolled, because once the paper started rolling, you're hard roll time. And you didn't have much, you had to be able to jam in your line before the laser hit the end of the page and swept and began the next line. And the paper rolled forward at a constant pace. It didn't move a line, move a line, move a line. The paper rolled as an analog thing, and the laser kept up with the line being horizontal by being tipped a little bit and sweeping, and everything was perfectly timed, right? So if you didn't have the image pre-compressed and you were starting to try to jam it in, you would overrun the end of the line, the time budget, and the little bit computer would begin reading your uninitialized bits, and he'd get confused and you'd get streaks across the page and stuff. That was obvious. That was more common failure. The Postscript clone failures were if you did stack overflows and you did divide by zeros, and that divide by zero had an easy semantic. There was some other failure that was more common. Run off the end of arrays and stuff like that. You just get a crash where you try to run these large test cases that you didn't care about the page, or you knew what the page looked like as a bitmap. So we could have a golden image bitmap go run. It's fine. Later, we got more aggressive. We had a farm of machines they sold a tool for this. It was a power cycling switch that you could run from some other place. So you had a bunch of cheap ass PCs that would be running these tests and doing bit checks and whatever they're doing. And if the PC hung, so it was like DOS days, like no Windows, this is DOS. If the PC hung, the timeout got it. And the master guy power cycled the PC, literally power cycled the PC, who then booted and came up and then continued on his list of things he was supposed to do. And you got the error report at the end of the day, or the next morning you came in and checked who did a timeout fail and hung and who did what. It was testing. Continuous integration in the 70s, I guess 80s. 80s style continuous integration.
Okay, guys, I have a question. How do you approach academic papers? How do you read it? Are
you trying to change the topic?
No.
Yes, you are. And it's good, because this is like getting old.
Yeah.
Well,
No,
first
what
I
he's
read the
saying is-
title, and 9 out of 10 times I give up on it. And then I
what
read
he's
the
saying is-
abstract, and 9 out of 10 times I give up on it. And then I read the introduction, and 9 out of 10 times I give up on it. And then I read the conclusion, and 9 out of 10 times I give up on it. And then I read the whole paper.
There's an exponential drop off of what actually makes it through to where you're actually going to read it. Yeah. Honestly, I'm there too.
Yeah, I the last big paper, it was one on the garbage collection, Imix. Well, I actually read other papers since then, but that was like the bigger one that I had issues with. I read it, a couple of times, gave up, read it a couple of times, back and forth, and I was like, fuck it. And I just emailed the authors. I asked them like 15 questions. And then through that, I kind of understood it better.
That usually works. Yeah.
Most papers, unfortunately, they become like a hobby project to read through them, basically.
Yeah, right. So when I started down this path here, nice seeing you, Will. When I get to the point where I've read through 3 or 4 papers, like intro and first section, and not understood it, I switch tactics and I start watching YouTube videos of tutorials on the topic. And I start watching, and I read the Wikipedia article on a lot of these things is fairly straightforward, or it links to something more straightforward, and I can chase a few links down and suddenly get a gist of what's going on. And between that and tutorial videos, I'm often to the point where I can make it through the first section. Now I can go to the second section. And then some of the shit I just drop, like denotational semantics I suck at. I kind of read them a little bit. I kind of get the impression of what's going on, and I just let it go at that.
I hate to say it, but a lot of academic papers are 40 years behind, it seems. I mean, they're like, hey, look, we managed to build a half adder with a carry bit. And it's like, wow,
Yeah, we've formally proven that our half adder with carry bit works.
right.
Yeah.
And they did like 60 pages of it. And it's like, holy fuck, like 60 pages of dense text for like the most basic concepts. So So yeah, I often give up just due to
Yeah.
I find papers have gotten worse though. If I read some of the old papers, like the old self papers or some of the old Smalltalk papers, you read through those and you go very quickly, this is what they're trying to do. I get that, I can implement that. You read a modern paper and there's so much syntax and garbage around it. It's like, okay, it's going to take me, a week to really get through this to the point where I'd want to implement.
Yeah, I'll agree.
Okay,
with
why this is now the gold standard? The paper is basically full of math and full of formulas and
But it's not full of math. It's not full of formula. It's full of formulas that are meant
Okay.
to look like math because computer scientists want to pretend that they're as formal as mathematicians, but they're not. Like it's fake math. And so
I'll
it's
claim
like,
that the papers I've been reading on Hindley Milner have very formal math that they're very carefully being very formal about, which makes it a bitch to read unless you're just totally spot on the formal math part. So I think there's formal math there.
hint. Once you understand it, the things that they're trying to say are so simple that maybe sometimes are even not worth mentioning. But when you see it in the equations, it doesn't.
Right.
It's
Yes.
not obvious. Yeah.
Yes, this is the frustrating thing. I got the web blog from the one fellow, Lionel, that was entirely readable, and he steps through the code piece by piece and builds out a Hindley Milner with subtyping. And then I go read the academic papers surrounding these topics, and they are just dense as hell in math and unreadable. And yet, they're talking about the same goddamn topic. And why is one so readable and one not? Come on, guys. Fine.
Yes. When I first started my academic career, I thought these grad students are so brilliant, no one can even understand the level they're on. And now I've realized these grad students are such terrible writers, no one can understand the level they're on.
Exactly.
That my appreciation for the talent of the people who wrote my undergraduate textbooks has steadily increased, and realized boiling a sea of papers into a proper textbook is a real skill.
That's interesting.
And I believe that writing paper is a developing part of your portfolio, and the more hard to understand, the more academic they seem, the more revenue you gain in these papers. And yes, it is.
I think
it is
there's
about
something
business.
to that. Yes.
Yeah, it is about business. It is about jobs. It is about some kind of presenting yourself. Once you write something on the paper and make it look like a complicated math, wow, this guy must be really brilliant, or he doesn't know what the fuck is going on this paper. Either
Has
that.
anyone else had the experience where you're trying to explain a paper and the person is like super confused, and then it clicks and they're like, right, but isn't that obvious? How did you get a paper out of that? I feel like this has happened to me multiple times. And by the time the person understands it, they're like, wait, but that's obviously right.
Yeah, right.
I'm kind of lucky because the Sun Labs group is a big chunk of the Sun Labs group that works on the languages stuff is like 2 miles away. So anytime I hit a paper I can't parse, I take it to them and I'm like, explain this to me. And they're like, well, he spends the first page trying to explain what his Greek symbols are going to be, which is all obvious because there's only 2 ways to do it. And he's following this professor instead of that one. And then the next page, he's simply explaining that 1 equals 1. So he's explaining the identity, it's like,
right.
And then basically the rest of the paper is just laying out, and it'll be like some tiny point he's trying to make, and it's 6 pages more of text to do it.
Right. But all the academic papers I've read in the compiler theory land,
I got to get the papers you're reading.
But back in the day, they all had to have a section where we laid out the basic terminology we're all going to agree on, because people use different jargon words to mean subtly different things. So you had to have this section that was just like 1 equals 1, identity is identity, this is this, and that is that, because different camps and different universities were using different symbols to mean slightly different things. It was a mess.
I would love to share a currently open GPT-3 instance on Discord, which for me at least helps me find some answers in the back of the book. It's in the chat. So one more method.
Well, yeah, I haven't looked at GPT-3, but it looks like it's random number.
Through prompt programming, you sort of have to lawyer language your way to something relevant that is useful to you, but it's pretty comprehensive.
Okay.
Yeah, GPT-3 is great because it's clearly not intelligent, but it forces me to think harder about my definition of intelligence.
It's a bit like GitHub's Copilot, where they introduced it, and they're like, hey, you can have Copilot to help you write code, and it will spit out just copyrighted code and Quake source code like verbatim, that sort of things. Like, gee, this is a really clever machine learning thing. I could have written that too. Just be like, if starts with GPT or whatever, or Quake here, copy paste, done. You don't need machine learning for that.
Just so you know, we are helping to our future overlords. So I'm just saying it now. 20 years from now.
So in the future, you won't have this problem where it's like, oh, who wrote this code? There was an idiot. Oh, wait, it was me. It's more like, who wrote this code? Oh, shit, it was a computer. Now I have to fix it. Like, we'll just spend our days fixing code written for us.
There are already popping up papers by code written by Copilot that has security vulnerabilities baked in. There are already popping up papers about that.
But it is surprisingly coherent. The fact that I can start typing begin PGP private key and it gives me something that is in fact the product of primes.
Yeah, that's the thing.
Here's a valid PGP private key. Whose private key is it? It was somewhere on the internet.
But okay, okay. Well, how many parameters has GPT-3? They steadily increased it last time that I checked. How many billion parameters?
Wait. The parameter count of a neural net model is fairly unrelated to the accuracy and quality of the model. That there is some correlation as you get to
I have a point to make.
But I ran an ML company and we looked at the bajillion models and their fit quality and the like, and you do not need a billion parameters to make a good model, and a billion parameters did not necessarily make a better model than a million parameters if they were tuned differently. So don't listen to the bullshit about the number of parameters we have in our.
The number of parameters are unrelated to the ability to generalize an algorithm, yes, but the huge share of information that you can hold, like a database, like something is that so big that you can even code something like that. That's my point. The sheer information you can hold in these models is just such a big, there's nothing to do, there's little to do their ability to generalize information.
I would claim that we can hold a lot of information in a Wikipedia, the entire Wikipedia as a, however many gigabyte text as well, but that doesn't make it knowledgeable.
I mean, Wikipedia
that's my
is
point.
Pretty small. It's like 100 gigs for all of Wikipedia.
Is it? It was 30 like 5 years ago or 6 years ago, or well, 8 years ago. I would have said it gotten only a lot bigger, but maybe not. Okay.
Yeah, somewhere around 120 right now.
Wow. Because the obvious test you do is one of your ML startups is word count on Wikipedia. So, how fast can you do word count on 30 gigs?
Wow, yeah, a couple of years ago, I worked for a company that did like a review analysis of travel websites and such, and we use machine learning there as well, specifically natural language processing. And just it works. It's one of those things that's very powerful, but God forbid trying to debug it and trying to figure out why if it sees a black person, does it think it's a gorilla or something like that.
No racism in our machine learning algorithms, right?
Or why does it assign a negative sentiment to review whenever the word Obama is mentioned? Things like that.
Yeah.
These weren't actual examples we ran into, but they were sort of at that level.
Another thing I've learned is tags are directional. If you look at all of the Flickr tags, people will often tag their dogs as babies. And if you label someone else's dog as their baby, you're fine. But if you label someone else's baby as a dog, now people are annoyed at you.
Hey, Cameron.
Yeah, but that's the
We're
thing.
Looking
with
at your waist. I think that's Cameron.
That's the thing. So at least in my experience, I find machine learning quite useful when the end result is not logic. So you're trying to detect sentiment or basically patterns, whatever they are. But if you're trying to have it produce something that is executable or actually does something, I think that's where things sort of start to fall apart, because there's a whole bunch of context that you can't possibly teach a machine to know that, hey, wait a minute, if I have, a 200,000 line project, I probably should not be inserting Quake source code into it. It's probably not the best idea. But then again, there are people who do that. So it's kind of like, there's the Turing test to see if, if you can differentiate a machine from human.
I don't buy the Turing test. No, I don't buy it.
No, but that you should. I think there's a lot of people who wouldn't be able to pass that test because they just go.
That may be true. That may.
There we
be
go.
True, yeah.
So far I have not passed the Turing test. I've been working on it for a couple of years now. It's a game you can buy. It's a very good game, actually. And I haven't gotten through it.
Okay. Okay.
Am I the only person who ever plays computer games? Come on.
Well,
Never heard
not
of
ones that ask me to prove my intelligence. I get that every time I walk through, TSA security, prove your innocence, and I get really annoyed at that. So, not terribly excited, but prove you're intelligent. No, fuck you. That's my proof. Fuck you.
So trust me, Cliff, look it up. It's a couple bucks for the game, and it's very good.
The Turing test game?
It's like Portal. It's kind of the same. Okay, has anyone played Portal?
Yeah.
Anybody?
Well, I
Okay.
did.
Yeah.
Portal's ridiculously cool in terms of, I wish I thought of it.
In terms of teleportation. Yep.
I'm reasonably confident Cliff is sentient.
I don't know. It's hard to tell. But yeah, Turing test. Look it up.
Okay, fine.
But I will say those generative adversarial networks are getting pretty good at generating faces.
Oh, the face ones?
Yeah.
Yeah. The last time I did is this a real face or a fake one? I was basically 100% correct. But it was usually because the real person had a real thing they were doing and the fake person had no context in which they were sitting in. And you would just pick it out as, it's just like a vacuous face sitting in an empty room now. Whereas the other person was doing something. And then the doing was obviously a real person now.
There's also some things like for women, sometimes the generated faces don't have matching earrings. But like, you'd never see someone go out with two different earrings.
Right. That's interesting. I hadn't observed that one. That could be. Instead, I'm seeing now like every possible YouTube funny video thing, the women all have a face, whatever, facelifts, electronic facelifts going on. What do they call it? Filters. And it's so obvious.
Facelifts.
Yeah, well, that's what it is.
Okay, where this is going with the
I don't
networks
know.
in there?
That doesn't seem useful to me.
Will reach to something productive?
I was going to head down dating
Besides
websites,
generative.
but it's been a while for me. So,
I mean,
Yeah, my wife's
I would
telling me
say
you're
that
done with
ML is
that now.
productive now. Even simple
Right.
things like predicting how much electricity is going to be consumed in the next 10 minutes. And should you ramp up the nuclear power plant or ramp it down means we have to spend a lot less natural gas covering the gaps. Like the AI is already hugely productive.
Oh, I don't claim AIs
Yes,
are,
but
AIs are very
Would
productive.
you trust it to make
They're
the
just
right
not.
decision?
Oh,
Always.
yeah, instead I would say it's not that the AIs are productive. I would say that AI is not the right term because that's intelligence right in the name. Instead,
Okay, the
machine learning
automated
algorithms-
pattern recognition is productive.
Yes, machine learning algorithms are very productive. Yes,
Yes, I agree with this. Yes.
fine. All right, let's change the topic here. Get closer to compilers and language runtimes.
So I was wondering if people have opinions on the distinction between like symbols and keywords and strings. That like all of our languages have strings.
Oh,
And I can compare strings and I can use strings as keys in my dictionary.
Yeah.
But like Clojure and Ruby and a bunch of languages have now decided we should have these keyword things.
Yeah.
That semantically are basically strings and you can test them with equality. But also, if they would have been equal, they also is each other. And they are the same pointer to the same object so that you know the comparisons are super cheap. But anyone can manufacture them. Someone doesn't have to give you a keyword for you to have that keyword. You can always make it.
Yes.
And I'm curious whether people think keywords are worth it, or like, we have strings, why do we need keywords?
Tarani?
Oh, maybe.
Is this like symbols in Ruby?
Yeah, basically symbols in Ruby, and I think atoms in Erlang.
Yeah, I've heard about this.
They have a couple of different terms.
Mike,
Sorry, go ahead.
My experience in coding in JavaScript was that strings do just fine for this job. That they were used for symbol-like things all the time. Compilers, the flow and TypeScript both understood them as symbols, really. But they're easy to write and easy to think about. So just
to compare them cheaply, they got to be interned, right?
Yeah, right. But you could intern them, or they would be interned. The compilers all knew that they should have, could have, would have been interned. Whether the runtime intern under the hood, I don't know.
Is interning Java specific, JVM specific, or is it broader?
No, it's broader.
That's where the term came from, was Java string intern.
Yeah, but anytime you're doing hash consing, you know what hash consing is. Let me start back up. Your hash consing, you know what hash consing is? Yes.
I know what hashing is, but not the thing you
hash consing. Okay, so hash consing says there's only one instance of an immutable thingy in the universe. Every time I make a new thingy and I don't know if I've had it before, I look it up in a hash table. And if I find a prior one, I use the prior one instead of making a new one. So it comes from the old Lisp work done by, God knows, I would say McCarthy and Guy Steele, where if the Lisp structures were immutable, you could make sure there's only one copy by hashing them, and then the cons was part of the buildup. So these things build up recursively. So if you have a bunch of atoms that have been known to be interned, and thus there's only one instance of them, then if you have a thing which is constructing multiple parts of atoms, this also can be interned. And as you go up the food chain, everything is now interned or a new object I don't know yet. So when I'm using them, as opposed to making them, when I'm using them, I can only have to do equality checks. And if I have large recursive structures, a top level pointer equals in one clock cycle tells me they're equal or unequal. Right, so it's, when it says no, it means literally no, it's unequal, as opposed to I don't know, I have to go look it up in the hash table. When I make a new one, I have to do the hashing function, I have to look it up and do things. And I use this all the time in compilers. C2's been doing it for 25, 30 years. AA's all full of interning, hash consing under the hood. It's a great efficiency hack. And when you go for the case of like strings, when you use strings as immutable enums or symbols or whatever, that then if you intern them, the efficiency becomes, it's a pointer and I can compare it for equality and it does the right thing. I don't have to call string that equals. So it's a useful concept for building complicated structures up and still having efficiency.
From a sort of user perspective, at least based on the last, 10 years that I've been working with Ruby, I absolutely despise the split between basically atoms and strings. Because they often end up being used not so much interchangeably, but you end up with, say, a hash map where in one case the keys are strings, and then further down the keys are atoms. And the number of times that has caused trouble is ridiculous. In fact, I spent this week dealing with bugs precisely because of that, because we were reading a structure from a YAML file. And prior to that, the sort of top level keys were symbols because the Rails, the web framework we use, does that. But the internal, sort of the nested ones were still strings. And our old code handled that fine. We made some changes where we used symbols everywhere, thinking it was going to work. It didn't because we used strings, and so some configuration settings would not be honored. It's a mess from a user perspective, and there is basically no practical benefit. Like assuming you have string interning, the same string 15 times only exists once, and then if you want to have a cheap comparison, like what I do with Inco, for example, intent strings, they have an extra bit set that indicates, hey, this is a permanent object. because they are. And the way the interpreter works is when you do string equality, or at least the string equality instruction, its first step is to say, hey, are these two strings we're comparing permanent objects? If so, just do pointer equality. If not, do full string equality and deal with that, basically. And so you do have the little overhead of like a check, but you know, it's comparing 2 bits, basically. It's just not that big of a deal.
Do you think you lose more time converting between the two different kinds of things?
Absolutely.
Than
absolutely.
what you actually win by being able to just make a constant?
Also, so to let's say like in Ruby, for example, specifically in Rails, this is such a big issue that there's various approaches. So there's a method where you take a hash and you convert all the top level keys to symbols or strings. There's one where it also does that recursively, because one wasn't enough. There's a type called hash with indifferent axes, where you create a hash map and the keys can be both strings and atoms. Doesn't give shit. Internally, I think it uses strings, but it does the conversion for you. And at that point, you have this sort of interning overhead, because every time you use if the underlying engine basically uses strings, every time you use an atom, you have to intern that to get the string out. And vice versa, you have to turn your string into an atom first. And the annoying thing there is this doesn't how would you have to best say, like it's very fragile, especially in a dynamically typed language. But even in a statically typed language, if you have like a function one that says, I want a hash map with strings as the keys, and the other one says, I want a hash map with atoms as the keys, you can't pass them interchangeably. You have to convert them and create an entirely new hash map. And I'm fairly confident, at least in a lot of Ruby programs, this is how you basically end up trashing the garbage collector. Not so much, converting symbols to strings, because that itself is fairly efficient nowadays. But having to sort of convert these data structures all the time, because there's like 2 different types that are like similar but not quite. So no, I would argue that it's probably best do string interning, do some clever checks so you can cheaply compare them, and forget about atoms.
You talked me out of them.
It's so I think Erlang also has them. I think in both cases they're kind of they're either inherited or they're sort of like a remnant from the early days. So I think Ruby inherited it from Smalltalk, if I remember correctly. I don't know if Smalltalk still has them.
They did.
Yeah.
Well, I think Smalltalk needed the distinction because they were comparing strings all the time for their dictionaries, and it was getting expensive.
It could be.
Walking the strings.
Maybe in the 80s, 90s, whatever, string interning wasn't.
If we were writing Smalltalk now, we would intern the strings. It's like fine.
Yeah, I think another example here again in Ruby. Ruby used to split fixed point integers and big integers. So you had a type called fixnum, which were 63-bit integers, I think, and then you had bignum. And certain operations would automatically overflow to bignum. So you do 10 plus a bazillion, you would get a bignum out. The thing is that bignum had some extra methods that fixnum didn't, and so you can end up with these cases where you think you're just passing integers around, but you're actually having types of different operations. And they ended up unifying that because it was quite a pain where you suddenly go from one type to the other. You try to save it, and now, I don't know, maybe you try to save it in the database, and the database is like, all right, don't understand this. It's basically, I think the sort of thesis, if you will, is if you have types A and B, and 90% of them overlap, I would just do one type, because otherwise you end up with this never-ending discussion. When should I use this one? And well, all the pain that comes with that.
I accidentally got that one when I wanted this one and this and that, and I had to convert. Yeah, I'll buy that. Makes sense to me.
Is there a way to arrive at unification that is both, the symbol level aliasing and type aliasing by virtue of the symbols being typed expressions, which can be aliased?
You're talking about string aliasing with symbols, or are you talking about symbols with types? Those are different domains.
But I think type aliases are good. String aliases, maybe they save some cycles.
Not
string aliases to multiple strings.
No, I'm not talking about.
That seems a little bit dodgy, but
okay.
Is there a way to use that as a typed expression?
So I think right. So I think we're confusing some concepts here. Strings that are interned, there's only one. Strings are not types. Types are not strings. Symbols are not types. Types are not symbols.
TypeScript would like to have a word with you. Strings are types.
Oh yeah. Fine. So now you have types that pick up some kind of symbol meaning with them as part of the enums are exactly that. And then do you want to declare them a string? And then as soon as you do that, then you're declaring your string is basically kind of a type, which is what the JavaScript folks ended up with. So I'm trying to figure out what you're asking here. Is there
it seems like type aliasing is a good idea. Symbol aliasing might be a little crazy in some circumstances.
Type aliasing is I have a short name for a large complicated type. I say class person and it has all the fields of a person without me having to list the fields again. That's great. Symbols typically mean like Monday, Tuesday, Wednesday, Thursday, Friday.
But
yeah,
aliasing basically be constants, or am I misunderstanding?
Yeah, that's what I'm understanding. You say aliasing here because they're constant. There's no overlap.
So you want to alias, MON with Monday, with the offset of 1 from 0 as all common meanings.
So that gives you two different names for the same thing, Monday and Mon. Are they strings that you're intending to mean the same thing, or symbols, or enums, or what?
Is that an expression that warrants type aliasing versus, ruling out two immutable strings having a common pointer?
Yeah, immutable strings won't let the string Monday and the string Mon line up. Immutable string says that two different Mondays are always the same Monday. Two different string Mondays are the same string Monday. And that's a nice efficiency hack in a lot of contexts. Space saving.
But I can certainly have a struct days of the week that has both a Monday field on it and a Mon field on it that both point to the same string.
Yeah, they'll point to the same symbol, which could be a string or it could be a symbol or it could be whatever. And that says that you have a type that has aliasing, it's representing aliasing under the hood. That's a structure. You actually you don't have a type there, you have a structure. You could have a type. No, now we're getting to weirdnesses where it says, I have a type alias of this name points to this type, and type alias of that name points to the same common alias type, which is maybe what Jim's asking. Can I have a enum Monday that's a type alias, not an enum. I have a type alias for Monday and a type alias for Mon. They both refer to the same enum because it's type alias. I think that's legit.
Okay, so it's a tuple, MON and Mon, and maybe, the integer 1 might, satisfy something as a tuple. But are there any, expressions that would conveniently be able to unify on one of those strings as that tuple, and do it cleanly and, add some value?
So the usual typing story there is there's a one-way type alias that is immediately executed by the typing system at typing time to go to the underlying representation. And that means the interning is done. Basically, it's an interning operation and it's done immediately at typing time, and you never ever see the left-hand side. You only ever see the alias right-hand sides, which if you've unified, you have, and but that's all done at typing time. Is that getting, because I'm hearing a mix of concepts when you're talking there, Jim, so I'm not following exactly which concepts you're trying to do.
Well, I wouldn't want to rule out that tuple use case.
Yeah, so wait, tell me, because I don't understand the tuple use case you just described.
Okay, so the Ruby example where there are a symbol and a string sort of unified. It seems like it might have a place, but
There's no
in
tuple
Ruby, it's done in a way that has some side effects that might not be great.
So what I just heard was I have a string which refers to something, and I have a symbol Monday which refers to something, and I want them to refer to the same thing. There's no tuple in that conversation. There's two one-way pointers from a string Monday to a thing and a symbol Monday to a thing. And in the land of what type analysis typically does on those things is if they are types on the left-hand side, type aliases, you just replace them with the right-hand side and you're done. That's a one-stop, one-step operation. Everyone's now referring to the complicated thing, which is whatever you're trying to alias to.
So I was recently exposed to this auto. I'll have to come back to it and look a little further, where every piece of an equation, a math expression, is symbolic. And so for your Kotlin compiler, it does not specify what type of float or double. It just uses a symbol and a template parameter. And then it goes on and on to create something which is then generated to some kind of IR, which goes to a whole different language and comes back with, possibly an OpenCL kernel, and goes back into the, executing VM and performs a value.
Right.
So in that context, a very simple example would boil down to a very immediate result. Whereas if you had, symbolic tuples, would they look the same in context of, boiling things down?
Yeah, I think you need to get more concrete than that and put something in the doc. Or the
Let me
chat.
come back to that.
Yeah. Because there's a lot of ways that one could go, and it depends on who's doing what. I know there are people who'll take some kind of math expression, go to a private compiler for it, and come back with compiler IR or another programming language implementation, whatever spec of a kernel to go execute something where they've optimized. Like the FFT guys go crazy and this kind of stuff, but a bunch of people do the same kind of thing.
Yeah, so the term Autograd is what I was reaching for. Okay. Autograd is this concept of, whatever, optimal math unification from whatever template language provides it. So it seems like that.
Yeah, it reminds me a little bit of Clojure spec, where someone's like, okay, here I'm specifying all the different kinds of things that can come in. And it's like, they could give me a true or a 1 or the string yes or the string true. And it's just going to conform all of that to a true field.
I looked up Autograd and got the automatic differentiator, and it takes an expression and does a, Python has some sort of expression written in Python, and it's going to give you a gradient, which a differential out of it. And as soon as you have a gradient, you can use gradient solvers to go, solve your equation. So it means it takes some sort of mathematical representation of a large equation, which could be very complicated in terms of having control flow and function calls and everything else in Python, automatically build a gradient function for it, and hand it back to you, which you can now hand it to various solvers, which will run the gradient to do a solution. That's what I got when I heard you say Autograd. Is that what you meant?
Yeah, I associate that with the value proposition of the Ruby hack that, sort of doesn't go far enough and creates a sort of dangerous situation. But in terms of type aliasing, it seems like it's in the same family. It's just implemented badly in Ruby.
I don't think there's any type aliasing games going on here. Because
what do you mean by type aliasing?
Yeah, right.
Can you
give
example?
Simplest type aliasing is, two names for the same class, even parameterized.
What does that have to do with Autograd, which does symbolic arithmetic, but it's not type aliasing?
It's
type aliasing
intensely
is
type aliasing in the implementation I've seen, which is not the Python. It's in Kotlin. But
the essence of Autograd is doing a differentiation of a complicated function that's presented to it. That has nothing to do with type aliasing. Whether it's implemented in Kotlin that way or not means that Kotlin's implementation has a particular implementation style, it includes type aliasing, but is not necessarily, there's nothing about differentiation and type aliasing that make sense together other than one's an
the
implementation.
two maybe it doesn't make sense a lot. Type aliasing is very different than auto differentiation.
Yeah.
In this sense.
Yeah. Type aliasing is a shortcut name.
Yeah, it's a way to give another name to already existing type, with a few exceptions, but basically you can refer it to something and give it another name that gives you a limited ability to abstract over the types that was an alias type gives you.
Yeah.
Do you want to be able to elevate, two non-identical constants to be, the same thing in an expression that is, possibly interchangeable with a single constant?
So in the land of most typing systems, a constant integer and the classic int64, int32 types is exactly that kind of aliasing. But it's not really aliasing because there's a subclassing relationship going on there. A 3 is an int64, and int64 is not a 3. That one's sort of well understood. And in fact, if I go to an auto differentiator, I need to know if I got an int64 or a 3, because the differential of a 3 is 0. But in N64, I need to know where it came from and the math involved to build it.
Okay, so I didn't want to summarily throw out the Ruby use case as invalid or a thing to avoid. It just may be a hack. But I don't know if I would want to implement that kind of aliasing twice, once for types and once for symbols.
Well, symbols would be, oh, I see. Yeah, that's fine. The one at types is done by the compiler. The one at symbols is done by the user at runtime via interning. And one of them has the user write interning code, because the symbol, unless the symbols are going to be interned for you, like Java constant strings are interned for you. If I write quote Monday quote, it's interned.
I think I have a question.
Yeah, I don't want to have to type.
Yeah, I don't want to say so, interned. Yeah. Sorry, go ahead, Jim.
Say again, Jim. I didn't catch what Jim said.
So yeah, I'm not the foremost expert on HM, but it seems like a class system with promotion and demotion could accomplish this, by reduction, and it would still make sense.
Okay, I'm back to what is accomplish this? What is this? What are you trying to accomplish?
Would be able to associate a type with a tuple of, valid references to a single pointer, ultimately.
Yeah, you could do that with a dependent type system, with a sufficiently advanced dependent type system. But
yeah, I'm trying hard not to go to dependent type systems.
Well, actually, I'm trying. I spent all last night while I was sleeping trying to figure out how to add it. So
don't do it. Don't do it.
Oh, I love it. I think it's brilliant. I just can't quite.
If you consider adding, you may be considering such somehow a termination checker, because the dependent types.
Dependent types don't necessarily terminate.
I will throw some link, system called 482, so that is a determination checker of Agda, so you can look at.
The good news is I didn't understand any of the academic papers on it, so I should have no problem implementing it.
Excellent.
It's kind of short paper. I'm still I'm still approaching my way into it, but it's a cool paper. It's a few termination checker, I see.
I'll claim, Cameron, that there be dragons there that.
Oh yeah, so no, like, because you have to deal with all that crap all the time. Anytime you're working with, constant analysis or anything else. So the question is, how broad a net do you want to throw for dependent types? And actually, the answer I came up with in one of my sleep sessions was that you only want to capture sequential types.
So describe sequential types.
Sequential types are types that have values that not only are predictably, dependably guaranteed ordered vis-a-vis each other, but that their ordering forms and keep in mind, I'm neither a computer scientist nor a mathematician, but it forms a total ordering, what's called a total ordering. So, so an integer, for example, is sequential, but a float, well, you can stretch the definition of a float, but generally speaking, a float would not be sequential.
Okay.
You could posit, depending on how you design the type for your float, that a float could be totally ordered because of the IEEE.
Yeah, but the IEEE 74 spec would say you just add an ULP and you got it.
Well, it's not so much adding an ULP that there's a function for every value, not counting nan or negative nan, or signaling nan or non-signaling nan. But there's a function for every value that returns the previous value or the next value.
Yeah, outside of nans.
Outside of nans, and you can't get a previous value from infinity, right?
Yeah, and I don't know if -0 would screw with you either.
I think IEEE 754 screws with you, so you're already on thin ice.
No, I mean there's no previous and next on a -0.
That was me joking.
So at least NumPy's previous and next. The thing before infinity is infinity, and the thing after infinity is infinity.
Yeah,
seems right to me.
Yeah, but is the thing after max float infinity?
Yes.
Right.
The thing before the thing after you is not necessarily you, because if the thing after goes to infinity and then you come back,
right,
you might still be at infinity.
Yeah.
So Cliff, you'll like the reason why I want dependent types though. And it's because I want to have a type called int. So right now our int type is simply an alias, tie into the earlier type alias conversation. Our int type is simply an alias to int64. So when I say int x equals 0, what I really mean is I want an int64, take the int literal 0, convert it, hopefully at constant compile time, to an int and store it in x, right? But I want to be able to write a function. Say, let's go with a Google stole the code from an Oracle case of a max and min, right? So I want to be able to compare two values and tell you which one's the larger and smaller, right? So the value is of type t, where t is some int or some integer number type, right? It might be an int 8, int 16, int 32, int 64, int 128, whatever, right? Signed, unsigned.
Do you have all the signed ints as a subtype of some top int?
I want to answer your question later, so I don't derail where I'm headed with this. So so basically though, what you want is from a language perspective, not a runtime perspective, but from a language perspective, you want to be able to write code that the developer chooses the type int, and then the compiler chooses how big it should be. Not the compiler in the C sense, the compiler in the hotspot sense. In other words, so far I've been interpreting this and I've never gone above 53. So I'm going to use a int 1, right? And, sorry, int 8, depending on if you suffix with bytes or bits. So an int 8. And then later on, it's like, oh, it's getting too big. I'm going to rewrite this code using int 16. And later on, so it ends up having 10 versions of this. And so when it could have multiple versions of the code for multiple sizes, but the developer who wrote the code never had to deal with that challenge. So you get the benefits of a varint, which we also support, but without the runtime cost.
I have a different take on that. all
Cool.
integer math on a modern processor up to 64 bits is essentially the same cost. And furthermore, because
Not
of the nature,
divides, but yeah,
I'm sorry,
multiplies are about the same. Divides are a lot slower for 64-bit.
over 32 maybe, but divides are also extremely rare. So let me press on here as well. And that the interesting, when I want to truncate the value decision is when I have when I want to store it in some sort of permanent storage and get it out of the I'm just doing generic math mode. And the storage point has a decision that he makes of I'm going to truncate you to whatever size. And then when I pull it out of storage, I'm going to inflate it via the usual sign zero extension rules to N64 and carry on. And then I'm asking the programmer to make a decision, what is the storage class? And that's the truncation rule that will be used. And almost always the answer is either I don't care, so I'll just use N64 and there was no lossage, or I do care, I care dramatically. I'm going to tell you this is a byte sized when I store it down, and I'll just truncate to the byte as accordingly. Right, I have 1 billion bytes, it matters a lot. Over 1 billion ints, certainly over 1 billion wrapped ints. But if I'm just doing fucking int64 math, I'm not going to deal with overflow unless you tell me that this can overflow and I should be doing big integer things. So like programmers typically know if their int64 is going to overflow or not, and if they care, and usually they don't care and they're never going to overflow and no one wants to write anything, that's it.
Yeah, that's my point too. You don't need dependent types to pick what the implementation of int you want. You typically can figure it out at compile time.
Yeah,
I'm still trying to figure out what do you mean by dependent types, because the dependent types, let's take a function that takes an int and returns an int. If you try to make it a dependent type, the int will return a type. What type would depend on the value of the integer you pass it in.
maybe
that's why
jargon problem here.
Mm-hmm. That's why that's why you return a type. That's you typically spot a dependent type system when you return a type. Nothing else can return a type. The value of the integer will determine what the type will be.
Yeah.
You can have more complicated cases in, let's say, a typical to figure out between 2-3 types, but base it on the integer, but that still make it to pick the type based on the value.
Yeah.
But I still feel like I want 3 things that I can say when it comes to overflowing an integer. It's nice to be able to say this thing should overflow to big int if it needs to. And it's nice to be able to say this thing can wrap because wrapping is much, much cheaper. It's also nice to be able to ask for the Rust style thing of this should not wrap. If you can't prove it doesn't wrap at compile time, give me a compiler error and be like, you added 1 to an int64, that could wrap around. Check that it doesn't.
Well,
which is a pain for me to write compared to the wrapping, but there's times when I want, if this can wrap, that's a compiler error.
Right.
Saturation is also useful, especially if you are thinking of vectorization and SIMD. The integers within SIMD lanes in vectorized arithmetic operations usually saturate. They do not wrap around. So the natural hardware implementation, if you are emitting SIMD code, is saturation. But it's not that easy to reason about this simultaneously with reasoning about wrap around in one programming language for one type.
Do most CPUs give you saturating add?
x86 does have the saturation SIMD arithmetic.
It's also addable in 1 or 2 clock cycles, which if you do a lot of integer math, that's going to blow you out. But if you don't do the wrapping very much, you won't care, or the saturation very much, you won't care. There's a test for overflow bit and jump around a slide a max int in. So it's a 1 clock cycle, 2 instruction kind of thing.
I haven't seen a clean solution to that in any programming language, to be honest, for the programmer to be able to say, I'll allow this type to saturate.
Oh, to saturate.
Yeah, I haven't seen a clean solution to that.
That's interesting. Yeah, right. I would claim it's so unusual that you would start with I wrote my own class that looked like integer, except it did saturating math. But then I had to write in a style that was with things that were capital I int sat instead of little int or whatever.
Yeah, custom types, but it's essentially SIMD intrinsics as well.
I can do overloaded operators for those things. And so they would do saturated math, and you could still write math like math. Maybe that's the
Yeah,
right
it seems like that should live in an intrinsics library somewhere.
Yeah, right.
That's like, if my CPU can do this, great. If my CPU can't do this, fine, I'll do it myself.
Well, you get a library that either bakes it down to what's the implementation. Same for the big integer. I want to say this will overflow to big integer. What I really mean is I want an infinite precision integer here. Now, whether the implementation does it as always a big integer, always wrapped, or the implementation does it as a int 63 with an extra bit that said, no, I've inflated and I'm now an int 64 and I have to deal with that and whatever. So that's sort of, you want to get that down to the implementation detail, get it out of your face. But you make a call. This is an infinite precision integer.
Right. It seems like a very good thing to have in your library, but not necessarily something you need in your language.
Yeah, not
But
right, exactly.
There's a value to being able to define an overflow point for a type like an int. To be able to say, in this case, I'd like these values to always be between 0 and 9. And in this case, it's somewhere between 0 and a billion. Like,
well, that's the saturation case.
It's less about saturation and more about it's more about a developer being able to explain what their intent is in a way that then the runtime has additional information.
Well, okay, so is the typing system guaranteeing that property, or is this an opportunistic assert that says, I really expect this to be less than a million, but I should blow out? Like, I have that kind of assert all the time. Here I'm running my trip counter on the work list algorithm. If I hit 100,000, I'm probably in an infinite loop and I need to blow out. But I just wrote that manually.
If you take an example, int times int, this operation potentially overflows if you pick large enough int. How, even with dependent types, how the compiler would know that the integer would overflow? It has to consider this at all cases unless it can know that these multiplication can fit in an integer.
I would claim that a reasonable answer is the compiler typing time would say it overflows. Now, what is the behavior you want for an overflow? Some cases it's saturation. Some cases I want it to overflow. Some cases I want to throw an error at runtime. In one case, I want to go to big integer, right? So what would you like to have happen here? And that's the tension about how you describe the situation. How do I give you one of now 4 opportunities? It's runtime test, runtime error, it's silent overflow, it's silent saturation, it's silent switch to big integer, and the performance that comes from big integer.
All those are just type distinctions at some level.
Yeah, but now write it fluidly in a language where you don't have to endlessly use weird syntax. Like if I'm in C++, I get operator overloading, so maybe I can write the type in the header part of the program somewhere that says this is a capital I integer or capital big integer. And then I just do integer math with +1s and divide 2s, and it all works. And it's silently slow because there's big integers everywhere and it's fine, but I can write reasonable looking code that happens to be big integer style. Whereas if I go to Java, I'm doing dot plus open close paren to add 1, and it like sucks to write it to use it.
Yeah, so there's syntactic sugar is separate from.
There is, but the syntactic sugar for ints in particular, because of their commonality, becomes an interesting thing.
Yeah, oh yeah.
My problem tends to be what's going to happen when I add A, a saturating integer, B, a wrapping integer, and C, a promote to big int integer.
What's the promotion rules when I mix them? Yeah, right.
Like, I can't think of a good way to solve that does not involve a lot of syntax where I'm like, okay, I'm going to cast 2 of the 3 to be the third type, and now I can do my add.
Yeah, I would make, but you could test me out here on this one. I would claim the default would be silent fast wrapping. If you mix types and one of them is the default, he will be coerced to the other guy, and then you'll do in the other guy's version. But if I have a flip to big integer and a saturated and I mix them, I should get a compile time error. I don't know if you mean
Yeah,
a saturated
promote
result.
and saturate feel like they conflict with each other.
They conflict. They should be compile time error. You need to cast one to the other.
I would say,
Again,
based
it
on-
boils down to the type rules. The types, the overflowing type has a rule. This is when you add this to, a wrapping type, what's the answer? Compile time error,
Right.
wrapping, overflow, you choose, right?
based on the experience from C with usual arithmetic conversions, I would say ban all implicit conversions in the language and always demand explicit conversions.
Okay. So you would
It's
say
a
the default is no good. Automatically converting the default to the other type is no good. Just
Yeah.
demand a conversion.
just explicit.
Okay, fine.
Because
The other question is I
it's
can ask-
terrifying.
So,
The other
if
thing
I
I
do,
can
but, if I do the default, if I don't have the default and I want to just add one to a saturating guy, I have to cast my one to a saturating one.
Yes.
The definition of the type involving saturation says what's the rule when the other argument is, a literal or, the unspecified type, or however you want to express that.
Right. So Keith and Matt here, you have two different conflicting opinions of which way to go. One of them I'm hearing from Keith is there's a set of conversion rules that get applied. We'll come up with a decent set. Matt says, no, never convert automatically, always throw an error, and may force the user to be manually inserting conversions.
So through all of this, I'm reminded of like way back in Pascal, we had, in the language, you can say, this type is the range of numbers from 0 to 9, right? And you can happily assign that to something that goes, -10 to +20. The compiler says, yeah, that's going to fit. There's no need for anybody to worry about.
Yeah, that's the main point. If it fits.
Let Keith finish. Let Keith finish. I want to hear this.
So
yeah, sorry.
I know that some intermediate languages, like the stab-s debug information, uses that kind of expression of what numeric types are like. I don't know why that didn't survive in more mainstream languages.
So when I take the thing that's from -10 to +20 and I assign it to a range from 0 to 9, that's a compiler error?
Yes, that one would be a compiler error.
Okay, and so I have to do a coercion and a range check, and how does that work?
So, again, I think this belongs in the type definition, right? So the thing that says I'm in the range 0 to 9 could be adorned with some other things that say, well, if you add, some unconstrained integer to me, it's still going to be 0 to 9, which is how you get wrapping or saturation or whatever you want there, right?
Well, I want a runtime test. I assert to you some complicated math I did on the -10 to +20 ended up in the range 0 to 9. Now I want you to declare it as 0 to 9 with an assert that if it's not 0 to 9, I want to blow out of the runtime error.
Okay. So the 0 to 9 has a method called, assert valid.
Yeah.
You call it if you need to, or don't if you don't want that.
Oh, you actually have to call the assert. Like there's not the auto conversion that takes a generic int to a 0 to 9 doesn't have baked into it a test and fail. It'll just silently do a junk conversion. It's like a untested cast.
Again, this all belongs in the definition of these types, and add whatever syntactic sugar you want to it to make it palatable. But in the end, it's the type that says
this is not syntactic sugar. This is unsafe.
Okay, so when we're in potentially unsafe territory, right? Then the type either has a method that says how to deal with that.
Okay.
Either by wrapping, saturating, throwing an error.
Right.
You defining the type. The person defining the type gets to define those rules.
Okay, but
users should be able to define types. Not just the compiler or language author. Right.
If the language lets you define a range, the language range needs to accept some sort of mechanism for converting into that range from a value that's outside that range, which might include type error, might include runtime error, might include silently saturate wrap modulo. I don't fucking care.
Exactly.
Okay.
Can't that just be if though?
Well,
I can wrap the whole thing in a if is my range type.
Right.
And it works. Else, You write code in the
Right,
else.
that's what I was looking for. What is the way that the compiler or the language supports that the user can implement the necessary coercion into the language? And it's like, yeah, I need an is-a test. Is it in the range? Then I can cast to the range.
The is-a test is part of the range type, right?
Yeah, that makes sense.
So you can write it whichever way you like, right? So if you like to do the explicit is-a test, well, then you add is-a to that type and use it where you want to, right? It's just, those just become stylistic issues.
Well, I'm asking, are you promoting the concept of the existence of an unsafe conversion from a number outside the range to the range declared type, but the number given is clearly outside the range? Or are you promoting the concept that always, if you get a range type out of the end, somewhere along the way coming in, somebody tested that it was correct, whether it was done at typing time, at runtime, it was always safe.
Yes, so the compiler will not do anything or should not do anything for you unless you've either used an explicit coercion that does the checking or the saturation or whatever.
Right.
That function returns something that is in range.
So it's always safe.
Yeah.
So always the ranges support a notion of, I'll take something that's out of it's unknown whether the range is good or not, and will give me a range back and either a runtime error or a type time error, some kind of safety.
Yep.
Yeah, okay.
So the way,
And in the worst case, if you don't handle it at all, it's going to throw. You didn't implement a way to handle this. Like,
well,
no,
right.
You get a compile time error if the type doesn't have a way to put it in range.
And now you have a compile time error potentially if it doesn't fit. And this gets into the how do you want to handle compile time errors and the like. And that one's sort of in the same camp as range checks that fail. Everyone gets a range check. What if it fails? Well, you can't type your way out of that. You got to actually handle the exception and every array reference. And now I've seen a lot of ways to do it. They're all ugly in their own different ways.
This is why it's important though not to have magic types like C and Java and whatnot, where it's like the compiler knows, oh, this is a 16-bit int and this is a 32-bit int, and so I can mangle these bits and do that. And all those things are just like hard-coded hacks, right?
No, the range, 0 to 65, 535 fits in a 16-bit, and the compiler can, use that fact. But
of course,
int 16 would be defined as the range 0 to 65, 35, and it's not special. You can define the 15-bit type or the 17-bit.
Right, but the point is that's defined not by the type; it's defined by the compiler, and there's a fundamental difference.
No,
there is no type library. There is no type library that says an int 16 does this and an int 32 does this. It's that the compiler has a line of code that says, oh, it's an int 16. I can assign that to an int 32 because I'm hard coded to do that.
No,
right?
I'm saying
that's a fun.
That's not in the. That should not be in the compiler, but in the library.
In the type.
Yeah,
right,
that's
exactly.
Cameron's case. State on that.
That's exactly what I'm describing. So, for example, when we have for our number type, it has a bunch of conversions defined among various number types, right? But then, like an int 16, for example, I'm just looking at it right now. An int 16 overrides the conversion to int 16 to return this as an example, because that's faster for whatever reason. And then it has a conversion to int 32, which is described as so it's annotated with an auto annotation, which means the compiler can see that conversion. So if it's asked for in int 32 and it has an int 16, it's allowed not to convert it. It's allowed to allow the type it's allowed to ask type to convert, right? So in other words, it's not something that the compiler knows. It's just the compiler has a library. It's looking for, it needs an int 32. It's got an int 16. What do you know? Int 16 has a way to give you an int 32. It says it's auto, so it's allowed.
You have to bottom out somewhere, or you're writing Peano math in your libraries.
Well, I've already described to you, we don't bottom out anywhere. I mean, that's
what I don't understand is that you clearly have to bottom out somewhere because something has to implement something.
No, but that's different. That's a different someone.
No, it goes to the trusted computing base. What is your trusted computing base?
No, so the compiler isn't producing the executable code. The compiler is producing the intermediate code. So the intermediate code is logically consistent. It has nothing to do with how it's actually implemented. Who cares how it's implemented? That's someone else's problem. You just push it down the line.
No. So somebody, somewhere your intermediate language has to bottom out, and you can't talk about things that the intermediate language can't itself talk about later.
Right.
So
He's saying each implementation has the right to choose its own axioms.
That's what I'm hearing.
There are multiple different bases that would work. Pick a set of bases that work.
That's why this isn't a semester project.
That doesn't sound like a good way to write portable code, because if my implementations have different axioms, I'll get different execution behaviors.
Well, they all ought to be consistent with the rules of the language.
Right.
And
it's
the
defined by
language,
the library and the language. That's it.
but the language ought to have the notion of an arbitrary precision integer. So whether it takes 72 bits to say this number, that needs to be able, you express that directly in that intermediate language, and then let the runtime worry about how to represent it and how to convert it to bigger or smaller types. And all that.
So what I heard Cameron say is, no, we define int 32 and by some other underlying construct. And I want to know, what is the underlying construct you define it by?
It's an array.
Of
32
bits?
is defined as an array of bits, and a bit is an enum.
So
and an enum
you
is-
understand an array. You understand array access, array store, loads. You understand range checking on arrays.
Those are all part of the interface of an array. Yes.
So that is the basic implementation for an array, and that's understood by the language proper, or is that arrays themselves built from smaller components?
Everything is built from smaller components.
Okay, so what is the smallest component that starts from something?
Nothing.
Otherwise,
We
I
don't
can't
have
ever
such a-
execute anything because I keep getting the next smaller part infinitely.
No, we've been through this. Come on.
No,
Like,
do it
we
again,
have-
because I heard it and I still don't buy it or
We have
believe it.
turtles. We have turtles the whole way down. It's
Yeah,
a
right.
logical construct.
So as soon as you have turtles all the way down, there's no bottom, so I can't ever
That's
get
correct.
to a piece of executable anything. So I
But
don't
if I
buy that
take
you have
an-
turtles all the way down. You stop it somewhere.
If I take an int at runtime, I can use reflection. I can ask it for its array of bits. I can look in the array of bits. Each bit is an enum. It has.
I have an array of bits. I want to ask the array of bits for its offset to its header, and I want to ask the array of bits that I want to do a load instruction into the array. How do I ask an array of bits without talking about integers? Because I'm trying to implement my integers, and I don't have any integers yet.
I didn't follow your question.
Okay, if I'm trying to implement integers as an array of bits, I now have an array of bits problem. How do I implement the array of bits without using integers? Because I don't have any.
No, but we used integers. That's the point.
You can't use them while you're defining them.
Exactly.
Why not?
Because you don't
Why
got a
not?
definition yet. If you do have a definition, then you have picked a lower bound
So
that you
what
want
language are we talking? What language are we talking?
English, but anyway, if
Okay,
you want the
now
third
English,
bit,
that word English, can you please define that in the underlying language so that I understand what you meant by
I was
English?
being facetious, Cameron. No, I mean,
I know, but I'm trying to make the point. Like,
Yeah,
we
I hear
don't
you.
base English on some fundamental underlying language. I don't have to look up each, well, I'm a native English.
Well, I don't
speaker,
know
kind
if
of.
that's necessarily correct. We all
No,
have
I-
some implicit, model that we use to understand things, and English is based on that. Some common understanding based on our own different implicit models.
but I'm still.
And for some people who learn English as a second language, I imagine there are actually multiple people in this chat. English is based on that language too.
Yeah, it's a different model.
Yeah.
But this is not, doesn't answer my question. It doesn't
I'm
solve
sorry
the
about
problem.
that, sticking English in the mix here, but I'd like to hear the answer to Cliff's question. Like, if you want to talk about the third bit in that array, how do you talk about 3? Because you haven't got ints yet.
But you do. I cannot bootstrap one without the other.
Okay, wait.
Okay,
Suddenly, you have put a lower bound. Simultaneously, I have an array of ints that talks about integers and integers that talk about array of bits. That is my lower bound that we have to agree as a closed cycle, but it is a sufficient baked
Yes.
in
Well, no,
minimal
we have a
set
core-
that's simultaneously alive. It's not turtles
We
all
have
the way
a
down.
core library, and that core library is the only
Okay,
bootstrapped.
right.
bootstrap
What's in the
that's
core library?
Couple thousand classes.
Okay, and how are those executed? When you boot up and go, you have bytecodes you're running that are talking about things that you haven't defined yet, or they have been defined. That's the key. If you make a closed cycle, it is not turtles all the way down. It's I
So
went
I'm
down
gonna
the turtle, so I got to this turtle, which talks back and forth these two turtles, and had to simultaneously create those two
So-
turtles
so
at the
the
same time. One did
bytecodes-
not come
the-
first.
The bytecodes are fully generic in a sense. That is, there is no bytecode that says add int 16 to int 16. Right? There is
Okay.
no bytecode that says anything about int 16 or 32 or 64 or
Is
whatever.
there a bytecode that says add?
There's a compressed bytecode for add, but it doesn't actually add. It simply references a method for adding. So
Yeah,
to
so if
add
I go
two
to the
images,
method for adding, what is it?
Right.
What does it have for bytecodes that execute?
it takes two arrays of bits and it does half adders across 64 of those.
Okay, so it walks to
And if there's a
arrays.
carry bit at the end, it throws an exception.
Hang on. It walks to arrays, yes?
Yeah.
Okay, so when it walks to arrays, does it have an index into the array elements?
Yeah, and the index
Okay.
is an int.
And when it has that int, does it make a function call to go get that int? It talks about ints directly.
No, it has to increment that int, which underlying has an increment, and the implementation for that is an add, which in turn then has to go down a level and add two ints, and that has to go down a level and add two ints. It's turtles.
Okay,
So
and
if I
then
want to,
then why do you not stack overflow when you execute this model?
Because the runtime's not that stupid. The runtime is not limited in its
Okay,
implementation.
what is the runtime doing that it doesn't recursively call infinitely down? Because that's your lower bound. That's your trust.
It knows that if you're not watching, it can replace an infinite stack of turtles with a 64-bit add on the processor.
Okay.
Is this what some people call a jet, where you have this specialized implementation of?
Yeah. It does. I got my jet. It does. It does a tail call elimination. And secretly under the hood, it took your tail call. It's the interpreter, honestly. It has to be the interpreter. The interpreter took your tail call and eliminated it. And that's your lower bound. The interpreter must understand tail call elimination of a sorts in order to not have integer math bottom out. I mean, never bottom out. It bottoms out because the interpreter does tail call elimination and then does a substitution of the code for integer math with a raw int, which immediately says there is a definition for raw int that the interpreter knows what it is.
Yeah,
and
so
that's
the
the turtle
runtime
at
is
the bottom.
allowed to substitute. The runtime is allowed to substitute an arbitrarily large amount of knowledge of this turtles type system to replace anything you're not looking at.
But it's not that it's allowed to, it's that it must, or else you will follow the turtles forever. And that's the lower bound, that's your bottom end, that's your bottom turtle.
Right.
There's an
but the
illusion of an
developer-
infinite pile of turtles. There's an actual turtle that bottoms out that says, I take this illusion of infinite stack and I treat it as if it's a single stack to do an integer add. And that's a required lower bound. That's what I'm talking about as your minimum.
Yes, but it's an implementation choice. It's not. It's
The other
not something
implementation
that's-
choices, I recursively go forever and I never actually compute an answer.
No, it's that if I have 5 different turtles that keep showing up in that stack, I can replace any one of those turtles with machine code. And I'm done.
But you must replace at least one of them with machine code.
That's
or
right.
you're
But which one do
never
you
done.
have to replace? And you're saying that you have to know which one you're replacing. I'm saying no, you don't.
No, I'm
It
saying
doesn't
you
have
must
to be
replace.
visible.
You must replace at least one.
Yeah, but I'm not arguing that.
Okay.
Of course, you have to replace at least one.
No, that's arguing. What I'm arguing then is because you must replace one, you have a lower bound. You have
I have an
bottom turtle.
unknowable lower bound. That's correct.
You have
You
a
cannot
choice.
follow-
The implementation is a choice of which turtles it's replacing, but it's going to replace one of them.
Yeah, and that choice is not defined by the language, if I understand.
That's right. It's not defined by the language, not defined by the library, and it's not knowable.
I'll bet you that under the hood that you must replace certain turtles directly every time, but you can change the names and shape a little bit, but the semantics will be you're replacing the turtle for doing integer math with
So
a
the idea is
integer math.
that as long as you pick up the turtles and look beneath them, it's a turtle underneath it. And
No,
whichever
if
turtle
I'm
you don't pick
doing
up-
if I'm doing reflective looking at things, then the infinite turtle pile is there. If I'm executing it, I have to do an as if rule, and if you don't have the as if rule, you never get anywhere. You only stack overflow infinitely.
Of course.
So you have to have an as rule, and you must know that you have an as. Well, you have to know you have an as if rule. And now I'm asking, what are the kind of as if rules? Yeah, you got
So
a
the
couple
point
choices,
is-
but not too many. I bet you
To go
really
back
have
to
to
the
have.
original point, Cliff, It's that we separated that domain, that decision domain, that responsibility domain from the language, from the types, from the libraries. And that's
okay, fine. I'm not buying that it's actually separated in practice, because I think you have to pick a certain set of turtles you cannot dodge. You must pick these turtles to replace. So it's all great.
Right, and that's mostly going to be determined by the CPU he's executing on.
And by the semantics of integer add. I think there's some Peano arithmetic math that you're just never going to dodge, that you must replace. And that,
well, it would be foolhardy to implement an int as an array of bits.
Yes, I'm not saying, I'm not talking about efficiency here. I'm saying, I believe due to the axioms of math, there are certain turtles you must replace and you will never not be able to replace. You must ultimately replace them.
I mean, if you're
you're either going to bottom out on a Turing machine or lambda calculus.
Yeah, right. And somewhere in the bottom, you're going to stop and say, dun, 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 this is the bottom turtle I'm swapping you out for.
I mean, you may think it's actually the bottom turtle is the CPU, but really they're sending bits over the network to some guy in Turkey who's doing computations on Mechanical Turk.
But still there's a bottom turtle, whether it's in Turkey. That's a very bad bottom turtle, but it's a great one. Might as well use carrier pigeons while you're at it. The hell.
Yeah.
Carrier pigeons are a little too slow.
There is a spec for it, 802.11. There is a spec for carrier pigeon Ethernet.
I think I've seen it now that you've said that. I remember.
I think it's IP over carrier pigeon. I didn't realize it was Ethernet frame.
Yeah.
I like to kind of.
All right. Wait. We're approaching 2 hours here. Let's wrap this up.
Okay, so just to kind of add to Cameron's point, perhaps, and you'll tell me if I'm wrong. But underneath, we don't know whether it's a 6502 where it only can do 8-bit math, or it's VHDL that can have arbitrary wide arithmetic because we're building the silicon as we go, or what, we don't know what's going on. So, I mean, I like the idea of abstracting even more like that, but in practice, it might be interesting.
Mostly, I'm just convinced that if Cameron was the one who designed the universe, quantum mechanics would be very weird.
It sounds basically like staging is implementation defined in Cameron's language abstract machine. If you think of language semantics as having an abstract machine, when you define what belongs in which stage, whether it's compilation, whether it's JIT, whether it's execution, you could hard code it like many languages do, that this is always at compile time, this is always at JIT time, this is always at execution, but you could let it to be parameterized. You can let stage be a parameter of your abstract machine, and it's obtain a family of languages, basically. And that sounds pretty much what Cameron has done.
But the rationale behind it is actually dramatically simpler than everything I tried to explain and apparently didn't do a great job at. But the rationale is that I wanted, in the design, I wanted everything to be expressible as a chain of function calls. So I don't actually want to implement an integer add as a chain of function calls, but I want to be able to express every operation as a function call.
Then you have to bottom out in Peano arithmetic, which is horrifically inefficient, but it works.
But the inspiration, Cliff, I hate to tell you again, I mean, the inspiration was the concept that Hotspot has, which is, if I'm seeing this chain show up over and over again, why don't I just replace it with a constant or replace it with an optimize, it's like this ability to recognize that pattern and swap it out with something that short circuits that chain.
So that's an efficiency hack. And the claim is you'll get integer math by an efficient jitting operation, although
right, integer math is the easiest one to explain because the integer comes from the core library, and the core library comes as part of the type system. Each type system is formed by either modules that come donated from a higher type system or that you explicitly add to the type system. Since the core library is that, as we talked about, kind of the conceptually bottom turtle, the first container that's formed actually gets the pre-formed core type system as a module that comes into it and is shared. That's the only way that different containers can talk to each other, is that their lingua franca, their English, as we were talking earlier, is the core type system. right? So if I don't share a module across two type systems, they cannot talk, right? Which means that if I don't share into that initial container, the core type system, I can't even call a method. I can't do the main if they don't share a type system. So there's this concept of container -1, right? Which is God, right? So God forms and closes over the module, which is the core type system, and then shares that module into container 0, which is where your main runs, if you will.
Right.
Now, what's really cool is that in container -1, there could be other modules that you are not able to see. They are unknowable because they're not shared into container 0, and they can't be actually shared into container 0.
Well, God doesn't choose to share them.
God doesn't choose to share them, but it's also, well,
I'm in the same
I'm
boat.
going in.
So going back to the base, I am trying to add two things. Where do I look for the scope of the plus function? If I have integer that wraps around and integer that overflows, and they do different things, and I have a plus between them.
We have integer that has plus, right? Has a method called add, which is annotated as an operation, as plus. So you look on.
So is it like whoever's on the left gets to decide what to do to the person on the right, or
that's
the object on the right?
Rule. That's your dispatch rule.
So for binary operators, it is a left associative rule, yes. But for equality,
not left associative. That's not. It's a left dispatched as opposed to both argument dispatch.
Correct. Left dispatch.
Okay.
Right. Equality is not left dispatch, but addition.
It's both dispatch.
But I might want to have it be tiered. It seems like a reasonable thing to say, I'm going to first check in my environment and say, is there a plus that is defined on both arguments? And if I don't find it, then I'm going to ask the thing on the left, does it have right add defined? And if that's not there, I'm going to ask the thing on the right, does it have left add defined?
So when you say when you say it's reasonable, it certainly is reasonable within any particular design of a language. But
what are you doing?
Well, what I was going to say is, if you look at, I think it's Julia does something akin to, is it Julia or no,
Julia does double dispatch or
Julia
full
does,
argument dispatch,
But I think it's an atrocious design, but it holds consistently with what Julia is designed to do. So it's like, if I were doing Julia, it would make sense. Outside of Julia, I look at it and I'm like, that's a hugely awful way to solve the addition problem, right? But yeah, we do left side, so left. So when I say A plus B, that compiles as A dot add B. And then the compiler simply substitutes a shorter opcode string for it. So our add op is simply a way of compressing byte speed.
Yeah, I'm doing something very similar, but then the question becomes, what happens to the thing that's B on the right-hand side if it's an int, if it's a float, if it's a Persian object?
But it's all type safe. So if I'm trying to add a string to an int, it's like, I don't have an add for a string. And the compiler looks at string and says, can you produce an int that's compatible? And the string says, I don't know how to do that. And the compiler says, you're trying to add two things that are not.
So you have another step in there, which is an automatic conversion request. Can you be silently converted into an int or whatever type? When you're doing type matching for calls, you allow arguments that are not left-hand side. So any of multiples or just on binary operators here?
So it's equivalent to the Java, what they call assignment convertible. So think about it like that, except the compiler has no idea what's assignment convertible one thing to another, right? So it goes to the types and it says, hey, type. I'm looking for this other type B. So type A, are you convertible to B automatically? And it either says yes or no.
Yeah, I'm there, except I've hardwired my decisions in. I don't like that. So this is one of the things I want to do with my typing is ask the question, are you one of the convertibles? Will you be willing to be converted? Question. So
but increasingly I want that to be in my scope.
Yeah, right.
Ints that wrap around don't know what to do with ints that overflow. Ints that become big ints don't know what to do with ints that wrap around. Like,
so the way we did
my environment has to be the one that knows this is what I'm doing at the call site
one of the risks you run into here is that you have to be, I want to say, deterministic or not ambiguous on these choices. And it's often the case that if I start doing conversions like that, I can reach a point where I have multiple conflicting stacks of conversions that all come to the same thing. And now come up with a guarantee that there is only one conversion.
Yeah. So we have a very big comment on the automatic conversion annotation, which is, basically don't use this because for that exact reason. No, I mean, how do you build something into a language that's powerful?
Well, I'm asking, what I am asking is, have you solved the problem of picking the automatic conversions such that you're guaranteed a single solution in any given expression?
Yes, absolutely.
Without telling the user, don't use it.
No, we will pick the one answer. And if there's more than one answer, it's an error.
Okay, but that's a fine.
Scala solution is the most elegant here, defining an implicit conversion. And when the compiler picks if there is an implicit conversion between this type and that type, if it's in scope, that's basically you define your conversion and compiler selects it for you.
So the implicits in Scala are in the ether. That's the problem, right? So they're not actually tied to the types. They're just floating out there, and the compiler has to know that they're somewhere that it can grab out of nowhere.
You mark them implicit, and compiler automatically knows if it's.
But it means that the compiler has to have a global view over everything before it can compile anything.
That's correct.
It's a trade-off because they had no choice because they were trying to interop with Java. So I'm not criticizing it. I mean, what they did was beautiful for the constraints that they had.
Right.
It can, but there I can imagine a version that just looks into the current scope if there is an implicit conversion defined there, not search the global scope.
Can I summarize what I heard the calling convention from Cameron was, and you can correct me if I don't get it right. You look at the type of the left-hand guy, you look at the function call name, you look up that returns deterministically a single function, you look at the right-hand side arguments, there may be multiples. Because you have a single function, you ask each of them in turn, do they have an automatic conversion to the type of the method involved? And if you get a yes on all of those, you do the conversions and make the call. And if you get a no on any of them, you declare error. Under that model, there are no ambiguities because you pick the single left-hand side. If there are multiple left-hand sides and multiple right-hand sides with multiple conversions, you now have an opportunity to be ambiguous. So
ambiguity is an error. Yeah.
Ambiguity is what?
An error.
Yes, but you have the second case where the left-hand side and the operator name, the function call name, can give me multiple choices.
Yes.
Okay, and if I have multiple choices, then there has to be only one that unambiguously is callable with all default conversions enabled.
There has to be, so when I have let's go back to a simpler case of, say, a method call, right? I have a method call called foo, but I happen to have 600 billion foos on a particular class for whatever reason, right? There has to be one unambiguously best foo.
Okay.
Right?
What does unambiguously best mean?
Unambiguously best is a combination of the inputs and the outputs, but basically each argument that I'm passing, the method that matches has to be, for each argument, has to be a more narrowed, the most narrowed for each argument. So if I have one that's like a generic int number and an int 64 and another that's an int 64 and a generic int number, and I pass 3 and 5, it'll be a compile time error because the one has more specific on the one and the other has more specific on the other. So it's ambiguous. It's actually based on the Guy Steele's work on the Java spec for, I mean, that's.
Okay, right. There's one best way to narrow the arguments.
Right. So given the arguments, given the types of the arguments that I'm passing, if there's any doubt as to which one's the best, if there's any ambiguity, then it's a compile time error.
Okay, and but the
So-
ambiguity, the best notion is I take the most narrow interpretation for each of the arguments after implicit conversions, I guess. I don't know.
Yeah, it's like, let me see if I can find. It's like
At least in AA land, it does feel like you could define it best and say, I'm going to join all of the things that can be in this tree, and either add is defined on that join point or it's not.
I do lookups for the function on the left-hand argument. I get multiple choices. I walk the choices doing the narrow. I do something very similar to Cameron is and maybe identical. I do the look for the unambiguously best. And then if there doesn't.
But is best the highest in the lattice or the lowest in the lattice? Or?
Yeah, depending on which way you call your lattice, but yeah. But I don't have the implicit conversions user definable like Cameron does, and I kind of want to be there. So there's a set of implicit conversions I'll do between ints and floats only, where if you have fewer conversions, that's considered better as well. Right, and then now you get kind of funny. If I have just two guys and the left is fixed, so the right is converted or it didn't. But suppose I have 5 arguments on the right, and in one set I can do 3 conversions to float, and the other guy I can do 2 conversions to int. The 2 is better than the 3, but it's not obvious by inspection which one you get. And I'm like, twitchy. Okay.
When you say 2 guys on the right,
you
have operator overloading that's not strictly pairs?
Well, so let me not do operators here. This is just a generic function call. I do have 3-way operators for array math, but just skip the operator. That's not the operator's issue. There's a left-hand guy with this pointer. He's the base of the lookup. He comes with a name for the function. He does the lookup. He comes with a set of functions, maybe the 600 foos that Cameron's talking about. Okay. The right-hand side set of arguments show up, and I ask a series of questions. So if you had the wrong argument count, that wins. Throw out everybody who's the wrong argument count. Within the correct set of arguments, you do implicit conversions, which for me, I count implicit conversions and say fewer conversions is better. If I have a tie on conversion counts and I still have 2 choices, I clear ambiguity and I blow you out. In addition, the conversions all have to be strictly narrowing in the way that Cameron was talking about, where everybody has to agree that they went to some particular direction. There's a class of overlaps I disallow. And this is not a well-tested section, but it's in the theory. So I'll claim that I'm not there, but that's the intent. There is a way to declare only narrowing operators. And also there wasn't a way to narrow this one and keep the wide one, or narrow the wide and keep this guy. They had to be unambiguous. That's it. They unambiguously have to be below each other in the lattice, all the way across the line, tied or below in the lattice, all the way across the line. If anyone's the other way, then I'm ambiguous. And I think that one is there. So his case of high and low and low and high, I'll also complain on. Sorry, go ahead.
Var args?
Var args, I'm doing the Java approach, which is to say, I'm going to declare an array. And it's syntax.
Right. Yes, you had already said that. You have to explicitly ask for var args at the end, or no var args.
Yeah. You have to explicitly ask. Currying, I'll also accept, but it's not implemented. But I totally intend to. That one's sort of straightforward. That's actually a parser hack, but it does fall into the camp of function call overloaded decisions. And I'll make it harder to fall into that camp. But if you allow currying, and I have more arguments and fewer arguments, do you mean when you pass the fewer arguments, you want the more argument guy with curry, or you want the fewer argument guy? And again, you have to follow the same rules for being unambiguous. You get more choices or more chances to be ambiguous. If you're ambiguous, I blow you out. But you have to ask for currying or you don't get it. You ask for currying at the call site, you told me which argument you wanted, which call you're having already. But if you ask for currying at the function definition site, then suddenly all possible curried flavors show up as more or less arguments, and you have to be unambiguous at that time. Yeah, auto conversion rules. Yeah, I don't have a good auto conversion rules. Like I said, I have them hardwired right now.
Now I figured out why I couldn't find anything. I had my wrong filter on my Finder.
All right, well, here we are at well over 2 hours. Been an exciting deep time. And counting turtles all the way down. I'm going to break for lunch. That was the lunch dash running behind me. Yeah, no, you were getting the cat and feeding the cat and whatever you're going to do. A magical mystery box showed up at my feet. I have to go open and find out what I got in the mail. Amazon was exciting. Whatever. Okay, thank you very much.
We don't really title these, but counting the infinite turtles would have been a good one.
Yeah, that might go in the Twitter short version.
Or what's that
Alright.
author's name? The Terry, the author with the worlds are on the turtles.
Terry Pratchett, I think. Is
Terry
Pratchett.
Pratchett. Oh,
This is
great
the Terry
series.
Pratchett special.
Great series. Oh, absolutely. Yeah. Okay. All right, folks. Until next week. Bye-bye.
Cheers.
Thanks.